Hello.
Well, welcome to Cpp.chat, a sometimes weekly, sometimes monthly look at what's going on in the world of C++, chatting with guests from the community. But an immutable part of this introduction is John's persistent disclaimer.
Thank you, Phil. I think this is very important that everyone know this. The information provided by Functional Remedies, we, us, or our, on the site is for general information purposes only. All information on the site is provided in good faith. However, we make no representation or warranty of any kind, expressed or implied, regarding the accuracy, adequacy, validity, reliability, availability, or completeness of any information on this site. So I want everybody to know that. We have a guest with us today, Juan Pedro, who has spoken a number of times at CPPCon, but he's broken my heart by saying he's not planning to come this year.
Yeah,
Oh, no.
I'm very sorry about that.
All right. Well, we'll miss you.
Yeah.
But tell us what you've been interested in recently, and you said you had an idea maybe for meeting C++.
Yeah. So actually, like the topic that has like preoccupied me the most over the last few years, and actually it's been like most of my recurrent topics I've taught also to CPPCon, is somehow value semantics, or how to make value promoting this thing that now Tony Van Eert and me are trying to push into people, which is value-oriented design. And yeah, so now there is some work I'm doing in basically some open source libraries to support this value-oriented design that I will hope to have fleshed out and be ready to show by the end of the year. Yeah.
Okay. So this is kind of in the path of some of the talks that you've given at CPPCon, right?
Yeah, exactly. Yeah. So I think at CPPCon, so 2 years ago, I talked about immutable data structures, which was
so let's dive into that, because that sounds just almost like a contradiction in term. Not quite a contradiction, but it's like, wait a minute, I'm storing data there, but if I store it, I can't change it. That doesn't seem right. So explain,
yeah, right.
What's the purpose of it first, and then we can talk about how those things work.
Yeah, exactly. So when we talk about immutability, right, it doesn't mean that you're refusing change. It means that change has to be somehow explicit and represented by different values, right? So when we say that it's immutable, it's the object is immutable. So the data structure object is immutable, but you can say, I add something to a vector or a map, and then you get a new version of the container with the new data in it. Right. So there is change in this sense, but this change is reflected as a new value instead of manipulating the previous object in memory.
So it's a functional way of looking at data stores.
Exactly. So this basically comes from functional programming. Even though, yeah, I've been trying not to refer to functional programming that much in my work lately, even though it's obviously inspired by functional programming. Yeah, and that's where it's coming from. Yeah.
Yvonne also seems to be running away from this term.
Yeah.
All right. So what's the point? What is the advantage of having a data structure that where every change to the data structure is essentially a new value for the data structure? Is that what you're saying?
Yeah. So there are two major advantages that come to mind like quickly. Like the first one is obviously for concurrency. Because basically, there is, when you're talking about concurrency, there is the hell corner, if you make like this diagram of state, mutable state, shared state, local state, non-local and not immutable, whatever. And there is the hell's corner, which is basically shared mutable state, right? So normally we avoid this by either, well, having state local, but that stops you from communicating,
right,
or by adding complicated synchronization mechanisms. But
which
if you
we all
make
love.
Which we all do, right? But basically, if you make things immutable, then you can share them safely between threads. There's no race condition if you remove mutability from the equation, right? So yeah, this enables completely new patterns of doing like concurrent programs where you basically share, you share by communicating instead of communicating through sharing. I think that word actually comes from the Go community, which is not particularly functional, but it's basically this idea of using message passing as a mechanism, to communicate between concurrent entities instead of, using mutexes and banging on shared memory.
Mm-hmm.
And now these messages, if they're going to be big and whatnot, you need a special data structures to avoid too much copying, and that's
Mm-hmm.
where these data structures come in play. Then the second advantage is that it's what I will call its value semantics, enabling value semantics at scale. Because I think one of the major problems that people face when trying to apply value semantics in the traditional, C++ value semantic way, right? Value types, at sufficiently large scale is that, well, value semantics are normally tied in C++ to deep copying, right? And as soon as you do, if you have like lots of data, then doing these deep copies, it's very expensive, and you end up basically dropping value semantics out of enough. If you make things immutable, you don't really need to do a deep copy to get a logical copy of the object, right? So you can actually, from the outside, these data structures, it looks like you pass them by value and that you get a full copy, but internally you're not really getting a copy. You're just copying a pointer to the internal representation. And the same things happen actually with these manipulation operations that I was mentioning before, right? So when you push something into a vector, you don't copy the whole vector to get this new manipulated version. You copy only a chunk of it. So as you create these new versions of the data, right, as you evolve the data structure, you're always keeping the history there if you want. But this history is somewhat compact because there is this property that is called structural sharing, which means that the different versions of the data structure that come from a common root actually share a structure internally, right?
Okay.
And this is enabled by this immutability, right? It's only like you don't see, like from the outside, you don't see, this, right? Like from the outside, it's all like independent values, etc.
So let me see that I understand, and we'll ignore how the magic happens. But for right now, let's say I'm running on a thread. I communicate with you on another thread. I want to give you a bunch of data. So I give you an entire data structure worth of data.
Yeah.
And that's safe without locking, because what I'm really giving you, some magic is happening, but I'm really giving you a snapshot of a storage so that after I give it to you, I can continue to add more and more data to it and then push it to you again.
Exactly.
And this never requires locking because you don't see the things that I add. Because what you got the first time is some kind of pointer into some data structure that is stable and never mutates. But I can mutate it. But when I do mutate it, I'm not changing what you see until I push it to you again and say, no, here's the new data structure. Is that how it works?
That's exactly how it works. Yeah. So
all right. Now tell me how that magic
it's
happens.
ability to get like snapshots for free, right?
Yeah. So now how do you do that magic?
How do you do that magic? Well, basically, I was giving some hint before, right, with this structural sharing. So the data structure is obviously not going to be completely flat. Like,
it's not going to be a single buffer like a vector.
Exactly, right? Because if you have a single buffer, right, as soon as you create a new version of the buffer, I mean, if you want to change the buffer, either you manipulate it in place, which is what we don't want to do. And if you want to have a new version of it, then you have to copy the whole buffer, right, to be able to keep it flat. But if you have something that is a little bit like a tree structure, then you can copy part of the data, right, the part of the tree where the manipulation is happening, but then keep the rest of the tree as it was before. Okay. So yeah, these data structures, even though sometimes they use names like vectors or hash map, that imply hash tables, they're never fully flat in the same way that a real vector or a real vector, a C++ vector is, right? What's a real vector?
There is some additional level of indirection to support the magic that's going on.
there is some additional level of indirection, yeah. But I mean that I talk about this more in the talks and whatnot. It's surprisingly low amount of indirection actually that you require. Like, for example, this library of immutable data structures that I built provides a type called immutable vector, right? That tries to have similar performance properties to a standard vector, but in this immutable sense. And iterating over it is just 1.5, like the overhead is 1.5 over iterating over a standard vector. Which is really low considering that basically iterating over a standard vector has it's almost like for free, right? And this is because these data structures in particular, or the data structures that I chose to implement to support these containers, they try to be cache efficient and adapted to the modern processors, right? Which is something that it's true sometimes you don't find in some of the community. Like it's a lot of it tends to be, if you look at the literature in general, often you find things based on small nodes and linked lists and whatnot, which C++ developers cringe as soon as they see this. But the science of persistent and immutable data structures has evolved, and now you have quite powerful data structures which provide very interesting trade-offs in this regard.
So how have you packaged this? Is this something that someone would find in Boost? Is it something that someone doing message passing using ASIO or the networking TS could just use as part of what they're working on? I guess you don't have any locks in it, right? So it...
Yeah. So this is a open source library. It's not integrated in Boost or any big package, but it's on GitHub under my name /Emer. That's the name of the library. And it's under the Boost license, so it's very very liberal license that anybody could use. And I know like a few people that are using it at companies already.
So it's ready for production.
Yeah, I'd say so. Yeah, I mean the API, I would like to work more on it. Like add more containers, add more stuff, but finding the time is always hard. Of course, I'd be happy also to find more commercial sponsors that would like to support some of this work. But I think that the data structures that are already provided, they're solid. They're, as I said, used in production and back reports if something comes up. Yeah.
And this was the subject of one of your CPPCon talks, right?
Yeah, that was like 2 years ago. I did a talk precisely on that topic. And last year I tried to continue the story a little bit, right? Because for me, this was basically the starting point, actually, of this kind of a story of trying to bring more and more value semantics to C++. So last year I did another talk, which was, on the one hand, a little bit like a prequel to actually the immutable data structures talk, because it was, talking about value semantics in general, trying to be a bit more philosophical and conceptual about it. But then it also talks about some of the basically designs that are being used for interactive software in the web world, like Redux and the Flags architecture, unidirectional data flow architecture is often called these days, which, as I say, I think it's becoming quite popular in the web and even under for some app development. But I think it hasn't really been heard much in the C++ world. So I'm trying to bring this here. Yeah.
But it's not language specific. It's more of a design approach.
Completely, yeah. And actually, in a way, C++ is a very good language for this kind of thing, because C++, it has value semantics as a core part of the language, right? Like if you're doing these things in Java, doing value stuff in Java is hard because there's no way to specify value semantics at an object level or at a class level. They have something in Java 9 that is still, I think there's still some quirks to it. And in C++, I think we have very nice tools for doing this. So yeah, I think we should be doing more of this. Yeah.
So you also did a talk on transducers. Was that before the Immu?
Yeah, that was in 2015. Yeah.
So what are transducers?
So transducers are also an abstraction that comes from Clojure, actually, which has the immutable data structures I implemented also come from Clojure. It's been a very inspiring language for me. And they are an abstraction for describing transformations over sequential processes, which is something that sounds very abstract. And to simplify, try to put it in one sentence, it's like a generalized version of the range algorithms, right? Like map, filter, and whatnot, that are independent of the notion of range. So you can actually apply them to a range if you want to, but you can apply it to other things that somehow behave sequentially. And most interestingly, to things that are push-based. So you can apply it to goods, or you can apply it to network packages, to things, sequences that happen over time as opposed to sequences that are already stored in memory somehow. Yeah. And yeah, that comes from Clojure. And yeah, that's from the time when I thought that selling functional programming to C++ developers was interesting, which now, as I said, I try to stay a little bit away from it and focus more on this topic of value-based design.
So what you're saying, I mean,
Yeah.
So this was one of the things when I read, which I haven't finished yet, but I'm enjoying very much Yvonne's book on functional programming. The first part of it, as I'm reading it, it's like, well, this is just good programming. This is just good value semantic programming, right?
Yeah.
There's nothing, then you start getting into function composition and stuff like that. And you say, okay, this is kind of weird, but the basic ideas are just writing really good code. At least that's what it looks like to me. And good value semantic code, right? And so that's what you're, at least I think of this. It could be that you start talking about functional programming in C++, people say, well, this is not a functional programming language, and I'm not gonna listen. But the truth is there's so much of a discipline there that if you follow this discipline of minimizing state and minimizing mutability and all these kinds of things, even if you can't get to the 100% mark, there's just at every level where you reduce that, you find you have code that's easier to reason about.
Yeah, completely. And I think like C++ allows us to take some of the functional programming principles, but apply it in an idiosyncratic way, right? So idiosyncratic or idiomatic in a different way, basically, that somehow reconciles often procedural programming and functional programming. Because in C++, thanks to value types, you can write a pure function in a procedural way, right? Like you can have, I take a struct by value, return a new one by value in the body of it, and just messing with the attributes and assigning to them, and I have a for loop and a counter. I can do, all the imperative stuff, but the signature of my function is still a pure function. Now, is this functional programming? I don't know, right? It's from the point of view of the API.
Don't tell anybody.
Yeah, I don't even want to know, right? But yeah, I think it's also like, I love functional programming, right? Like, obviously, but the reason I try to stay away from it is also a point of focus, right? I think like when people talk about functional programming, their first focus is, right, the implementation. And I think a lot of the value from functional programming comes not at the implementation level, it comes actually at the design and architecture level, because that's where you have many components, many pieces, and that's where having basically mathematical rules and actually limitations like you cannot mutate actually become important, right? When you have like not so many pieces because it's a detail, it's an implementation, then use whatever you want. Then the other thing is that I think when we talk about functional programming, the first thing people think about is tools for abstraction and composition, right? And this basically means higher order functions and then categorical constructions like monads and all this stuff, which is kind of scary for a lot of people.
That word. We don't use that word on this show. We all have to go run screaming.
Yeah, I'm sorry.
We'll have to edit that out, Phil, right? You're going to edit that out and post.
2 strikes and you're out. That's the rule.
Yeah, the M word, right? So the burrito, was it like?
But you're saying it's as much about design, or maybe the real value is in the design level rather than worrying about functions that take functions and all this kind of stuff, but instead just thinking about at the design level.
Exactly, right? So it's like, okay, that's part is fantastic, right? And it really helps you, makes your life easier. But yeah, when you're designing the system, let's think about our value types. Let's try to design our data model of an application, right? If you have like interactive software that's big enough, you want to have a data model. Can this data model be a value type? I have business logic. Well, can this business logic be implemented as pure functions, right? And for that, I don't need anything fancy. I don't need templates. I don't need, high order functions. I just need functions that take a value and return by value. It's like C++ 98, you can do all this stuff with the things that you learn in an introduction to C++ course. It's just about, leveraging this and working around the design constraints that you're imposing yourself, of course, when you're taking this value-based approach. And of course, you hit walls often, right? For me, actually, the first wall was, the deep copying issue, and that's why I made the Immutable data structure project, right? Like, and there are other walls you can hit, but yeah, I think like it's interesting to see like how far can I push it, like having simple value types and having, simple functions and breaking out of, I don't know, maybe the traditional more graph of mutable objects way of looking at software design.
And the payoff being,
we think
read about the code, more easily adaptable as concurrency.
Yeah, of course, that's clearly one advantage. Is that it's much easier to adapt your code to be concurrent. It's great for testability as well. It's very nice for decoupling certain kinds of things. Certain kinds of features are very easy to implement, like undo is one of the canonical examples of a feature that is very hard to implement in a mutable world, but that it becomes almost trivial in a value-based world. So yeah, I think it really helps with quite a bunch of otherwise complicated problems. And I also find it interesting, sorry. Yeah.
Well, I was going to say, it seems like your immutable data structure just invites the ability to roll back, right? You can do undos on that very easily.
Exactly, right? Because you can just keep around the old version, and if you want to undo, well, you just set the state to whatever it was before of the whole thing, right? Instead of having to implement, in the command pattern that they teach you in the design patterns book from the Gang of Four, you had to implement basically your business logic twice, one in one direction, one in the other direction, and store it as an object somewhere. Here, just roll to the previous state.
Mm-hmm.
Now, you don't even need an immutable data structure for that. Actually, if you're also applying your application logic as pure functions, you can also store maybe a snapshot, but not a snapshot for every single state, just one from time to time, and then store the events that happen. And since your functions are now deterministic, you can also just go back in time to your last snapshot and replay the actions until the present, which of course then becomes ON to the amount of things that happened between the snapshot and now. But it becomes very playful in this sense. Depending on the trade-offs, you can do one thing or the other, or combine them actually. But yeah, I think a lot of this also comes from a trend maybe of trying to break out of or beyond object-oriented programming. And I find also quite refreshing in the C++ community this data-oriented design movement. which in many ways it promotes a lot of the things we also talk about when we talk about value-oriented design. I think they just come from a very different community, and they have a different focus. Like they focus on different trade-offs, right? Where they come from the gaming world and they focus on performance beyond almost anything else. But a lot of the conclusions they reach end up being quite similar, actually, when it comes to designing data types, designing the data first, being explicit about your data and the relationships, being explicit about identity to be able to decouple data layout from entity layout. Yeah, so if you're excited about data-oriented design, I think that has become like quite hyped in the C++ world. I think value-oriented design maybe provides you like another way to look at a similar way to go beyond object-oriented programming.
So one of the things that you also talked about was unidirectional data flow architecture.
Yeah.
Does that mean you can't do undos? What does that mean?
No, that means basically that, well, data flows just in one direction, right? Which is a little bit different from how you normally design interactive software, where traditionally you have a basically mutation-based interpretation of the MVC pattern, the model view controller pattern, where you have the model, the controllers, and the views, and the view has Android, but then the model is mutable, so it also has to have callbacks pointing at the view back, and as soon as you modify something, you have the callbacks coming in, so everything keeps updated. And if you do it in a disciplined way, this kind of works. Like MVC is great in many ways, but it has quite some problems when it comes to composing things beyond what we mentioned before about concurrency and whatnot, right? The traditional example is that, well, if as soon as you modify a property in the model, it notifies via callback, then I cannot use modifications of this property as part of a bigger compound operation, because then I'm going to see invalid, like intermediate state in the UI, right? So, okay, that was like the MVC. With the unidirectional data flow, basically what you try to do is say, I'm going to have a similar distinction, but I'm going to have something I'm going to call actions, which is a representation of what happens in the world, some event. That it can even be already like a business logic kind of operation, right? Like, I don't know, insert character in a text editor. Then you have the model, which is a value. And then when an action comes, you evaluate an update function, but the flow goes in function, the model in place, it returns a new version of the model, right? And once you have this new version of the model, then you evaluate some view function, which just renders the UI, or maybe ideally, if you have something like React, returns a value representing the UI that then is dispatched to something that actually does the rendering, some mechanism here. So in these steps, things go just in one direction, right? Like you get the action, which triggers an update in the model, which returns a new value, which returns a new view state. And yeah, this solves a lot of these complications, actually, of basically composing models and of course also adding concurrency and whatnot, because once you do this, then your model ends up being value-based and immutable, and your update logic ends up being like pure functions. So yeah.
So this is a new world of trying to design user interfaces that are not based on object-oriented programming and using kind of the React model instead.
Yeah, basically, yeah. Actually, so a lot of this comes from a library from JavaScript that is called Redux, that is very often used combined with React. You need to React to use this library. There is also a programming language called Elm, which is basically like you could say like a simplified Haskell for doing HTML applications. And this language is very interesting because it basically embeds this design as the core of the language. Like in this language, you don't have a main procedure as your entry point. You have this update function, you have your model and your actions, and you define this, and the runtime combines this for you to get your interactive application running. And actually, I mean, when you look at it, it's so simple that it looks almost like a little bit stupid when you look at it. I think the only reason that has stopped people from doing things this way until now is that, well, if whenever you do an update, you return a completely new version of the world, this is going to be very expensive. You're copying everything, right?
Right.
But as we've seen with immutable data structures and all this stuff, this actually doesn't have to be the case. So this is, again, why basically the data structure work was the first step for everything that came afterwards in this value. Yeah. Yeah.
So
now, sorry.
Oh, go ahead.
No, I was going to say that maybe to introduce like the next topic that I would like to talk about at conferences, which is trying to reconcile actually object-oriented programming and this more value-based approach. Because of course this unidirectional data flow architecture, whatever, it's very nice, but it's very hard to implement if you're not starting from scratch, which is a luxury that almost no C++ developer has. Like a lot of the important C++ projects are, well, legacy, whatever that means, which just means, old but very useful software. So we have to deal with those constraints, and it will be nice. And I think there are some ways we can maybe try to reconcile the two.
Yeah, this is one of the things that I see a lot. There's something on the order of a decade of time difference between the topics that people are proposing to conferences, which is of course something I'm well aware of. Everybody is talking about. Some people are talking about already things they want to do for 23. In fact, there's a lot of, one of the things that we've talked a lot about on this show is static exceptions, and I'm all excited about that. And it's certainly not going to be in 20. So we're talking about that at 23. And in fact, some parts of static exceptions we might not see until after 23. So we're very farsighted. And this is what we're talking about. Conferences, this is what gets me excited. Well, you start talking about static exceptions, everybody knows you get me excited on this show. So, but on the other hand, when I go out to training, which is, how I make my money, I talk to people, teams. Often it kills me every time I ask this, but at the beginning of every class, I say, how many of you have heard of C++ Now or CPP.Con? And when I see like 4 hands go up out of 20, I take a minute and just cry. So an awful lot of people, they're not at the cutting edge. They don't really know what Working Group 21 means. And, so when you start talking to them about, some of these concepts, that's not where their head is. And they're very much in the object-oriented world. Now, there might be some of them even that think there is a better way and know a little bit about, modern C++ design. And when was that written? That was written back in, mid 2000s, I think, something like that, I
think it was 2000.
What? 2000?
Yeah.
2 years after the standard. Yeah. So that's, there are people who are aware of this, but even those people are often locked in a legacy application where you don't just throw away that object framework, which for good or evil is doing an awful lot of work for you and producing an awful lot of value to real world users doing real world work, right? And so we don't just throw that away. Now we got to figure out how do we make sense of, how do we capture people's ideas about what you're calling value semantics or functional programming or whatever we want to call it, newer ways of thinking about things which rely less on runtime and perhaps rely less on mutability and state and have a lot of advantages about reason about code. That's one issue. But the other issue is once people have gotten that, then you got to think, okay, now how do you use any of that in a world where every class we have has a virtual destructor and virtual functions, right? So that's one of the things that I have been struggling with a lot lately. In fact, that's why my submission to Meeting C++ is actually a talk on object-oriented programming, and it's like I don't know how it can possibly be accepted because it's like so 1990s to talk about object-oriented programming. But my feeling is there's a lot of people who are doing this, and we've stopped talking about how to do that properly and how to do it well, because most of the people at conferences, they're not all as advanced as you are, but a lot of them, they're not talking about object-oriented programming. They are talking about value semantics. They're talking about const expr, what can be done at compile time, all these kinds of cool things. And I just think that there's a lot of things that we learned in the 90s and the 2000s that are not being talked about by anyone because nobody's recommending books that are that old and nobody's talking about those things. So if you are an object-oriented programmer today and trying to do the best job of object-oriented programming you can do, where's your guidance? So that's why I wanted to do this talk, but I don't know if I can convince Jens to let me do it.
Well, I agree. I think it's a very important topic, actually, right? Like it goes, I agree with you also in this sense that it's true that, especially at conferences, that people want to talk about the cutting edge in techniques, right? Like the craziest like template trick you could ever dream of.
Which is right. They should.
Yeah, of course.
That's where you should do it. Absolutely. That's where it should
be done.
Exactly.
It's super fun, and we're pushing the edge of the language itself, and that's why we go there to mesmerize ourselves, right? But it's true. Like I think at C++ on C, like I made this joke in the introduction to the talk where I said, my talk is going to be 1 hour and a half of high quality C++ without the template keyword. It's true. I've talked about semantics. There was no template keyword, and everybody laughed. But it's true. Like I think we've lost a little bit contact with the basic tools and how to apply them to design. And we don't talk anymore that much about concrete designs and even like MVC and object-oriented and architecture and well, there are some refreshing, as I said, some refreshing trends with the data-oriented design. But it's true that I'm very happy also to have the conversation alive about how to do proper object-oriented programming. This maybe now trying to talk more about value-oriented design is just contributing to this conversation of, what are the design paradigms that C++ supports and how can we reconcile the different paradigms? Because, it's a language where in the end supports multiple paradigms, and projects that last 20, 30, 40 years or more, they end up having lots of these paradigms. And sometimes the architecture is a little bit of a Frankenstein. Sometimes actually these multiple paradigms actually complement each other for the good. So let's try to figure how these play with each other, right? And often, like I was saying before, like one of the limitations to apply value semantics is sometimes legacy code or legacy projects. Just if you want to use like a nice UI framework, like let's say Qt, right? And some people say, well, I'm going to write my own UI framework, and then they spend a few years working on a UI framework instead of their project, because it's a daunting task, especially if you want to support accessibility and all, and font rendering and whatnot. Anyways, let's not get started on that. Let's say you want to actually use Qt, and Qt has, it was written in the 90s. It has like a Java-style object-oriented approach. And let's say you want to actually use value semantics for your data model because you saw this cool talk about value semantics or whatnot. What do we do now, right? You have to have an answer to that part of the story instead of just having these toys where everything is nice because you wrote from scratch with whatever tools you could come up with. So this is what I'm trying to work on now more, which also comes from my experience. I work as a consultant as well, right? And so a lot of my clients in the end come to me because they saw what I talk about at conferences, and then we try together to see how to apply this in practice. And this basically means resolving these questions about dealing with legacy code, how to incrementally apply value semantics in a code base that doesn't, how to interface between a value-based module and an object-oriented module, and this kind of stuff.
Right, because if you say to a client or really to anyone, okay, the way to do this is to throw out everything you have now, that's probably the last word you're going to get out before they close the door or hang up the phone, right? That's not, exactly. That's a non-starter, right? So we figure out how to make this transition is really key. In fact, I in my talk on exception-safe coding, one of the probably the most important thing in the whole talk is in the last few minutes when I say, okay, this is the model for how you go from a code base that isn't exception safe, a code base that doesn't have, where the assumption is that nothing ever throws, so I don't have to worry about it. And now we want to take advantage of some of the power of exceptions. How do you integrate that in? How do you make that work? And there is a way of doing this, which has been proven on a number of very large, multi-million line code bases. There's a methodology for doing it. But without being able to explain that to people, then you can spend a few hours talking about exception-safe code only to have them nod and say, yeah, it really looks really good in your world, but in my world, that's going to be dangerous. And without, this is the transition story. And so I think we need to do the same thing. If you're going to change people around from thinking in terms of base classes and object-oriented framework, and instead think in terms of types and value semantics, then you got to give them a story to, this is how you get from here to here. This is how it can be integrated. And I think one of the things that's challenging about that is that part of the power of paradigms in general is we can make the assumption that all our code does this because that's what our paradigm is. And that's when you mix paradigms that gets really hard to do, because you say, well, I'm going to make the assumption that oh no, the code doesn't, because all the code done in this paradigm doesn't have that. And so you have to think about how to integrate these things. And it's not trivial, but if you can make it work, you can give people a path out of a legacy situation into a better design without requiring that they throw it away and start over from scratch. If you can pull that off, if you can show them the transition solution or the hybrid solution, and let them see an integration path.
Yeah, completely. In this case, actually, it's interesting because what I've been working on lately is also like library tools that help with this, right? Because in the question particularly of integrating object-oriented programming and value semantics, there is actually a tension where, when people say prefer object-oriented programming, they are right about one thing that object-oriented programming gives you that it's very good at, which is a sense of modularity, actually, that sometimes you lose a little bit when you move to a functional world to gain composability. And what do I mean by this? I mean that in an object-oriented world, I can have, let's say, I don't know, the typical example where you're making like a car, right? And the car has an engine. And I can have an engine view, right? That has a reference to the engine. And it doesn't have to know that the engine is part of a car to represent the engine, right? So this is kind of a sense of modularity, right? Like this view is concerned just with the engine because it has a pointer to it. Now, this modularity has some flaws because actually the engine can change in ways that you don't expect because there are other people having references to it. But at least in some sense, at least in a sense of physical coupling, let's say, right? There is this sense of modularity. If you move to a value world, right, and you say, well, because I don't know, I want to speed up, then I get a new engine. Okay, great. Well, the engine is part of a car. Well, now I need to also get a new car if I want to change the engine, right?
Right.
So this view that, let's say you have the engine view, now if it wants to change the engine, it needs to also how to create a changed car with a new engine. And maybe this is getting a little bit confusing, but you know, there are these challenges that you face when trying to assemble things, right? And it's because this tension, right? Like it was very easy to compose things to make the engine part of a car, but now it's hard to regain this modularity, basically caring about the engine without caring about the car.
I don't think.
Sorry. Yeah.
No, I was just gonna say I don't think it's a coincidence that the explosion of hype about object-oriented programming and the explosion of GUIs happened about the same time, right? I mean, it was the 80s and 90s when the Mac and Windows and Top View and all these other products were trying to introduce, you know, object-oriented programming, or excuse me, GUIs to the computing world, and they were all implemented or most of them were implemented with some kind of object-oriented programming model. I happen to think that object-oriented programming handles GUIs pretty well. It's a pretty good fit. Now, I've had long discussions with Sean Parent, whose wisdom in this area I certainly bow to, and he thinks that it's still better to use generic programming to do a UI. But I do think it's an area where object-oriented programming tends to work pretty well. And I think that it was clearly overhyped. It didn't solve all of our code reusable problems that we wanted it to, but it solves that particular problem pretty well. It's a pretty good match, I think. And believe me, I spent years doing this, right? I was a Mac programmer. I know a little bit about implementing UIs in object-oriented programming. It's a pretty good match for the paradigm. I'm always anxious to talk to Sean about how would you do this then? And you know, so interestingly, he comes up with some kind of interesting type erasure solution. It's like, oh, that is kind of cool.
Actually, I mean, I think so. I was proposing the problem. Of course, I think there is a solution to that problem, and I think probably we don't have enough time to really go into it right now. As I said, I will be talking about that at conferences probably next year, so there will be more chances to go into that. But yeah, I still do think that the value-based approach and object-oriented approaches are actually good for UI as well. And one of the big proofs is React and the great success of React, which really has completely changed how people do UIs nowadays, because most of the UIs now actually are in the web. But I have a lot of respect also for all the innovations that happen in the object-oriented programming world to support UIs. And I agree with you, right, that there was basically the MVC design and architecture came from Smalltalk and its very radical object-oriented approach. in this very kind of disciplined and almost like radical and utopian way of doing object-oriented programming, I think changed, like it broadened people's perspectives, right? And it brought a lot of this, modularization and it brought a lot of things to good things to the world of programming. But I think it's good now that now we're having a conversation to say, well, now that we also, I mean, the thing is also, it's very easy to criticize your ancestors from the perspective of now. It's true that also simply the world of computing is a different world now, because Moore's law is not valid anymore, and now computers are working horizontally. So maybe concurrency is much more important than it was 30 years ago, where even the operating system was single user.
Well, and also the compilers of that time were not up to the template things that we throw at it now. You can laugh at it, but I think at one point the standard had this section where it kind of suggested minimal limits to things. Theoretically, your compiler can say there's a limit to how many characters you can put in a variable name, right? So what is that? Well, nobody cares, because the practical limit of that is huge. But I think there was a proposal once that you should be able to do 17 levels of templates deep, which at the time was just astounding. And if you ever tried to do it, your compiler just turned into molasses, right? But today, if you couldn't handle 17 levels of templates, we would be in a lot of trouble really quick. There's a lot of people who are doing things way more complicated than that. But and today's compilers have to be able to handle that. So that's, I think, we are moving things from runtime to compile time, but that's not free. It's great for users, but it's only possible because we have compiler technology that just didn't exist in the 90s. And is beyond what anybody thought of in the 90s. And so, I think it's, like you say, it's easy to poke fun at or find fault with the limitations of previous generations' work of our ancestors, but they were doing miraculous things with what they had. And I think that part of our improving on what they've done is simply exploiting things that they didn't have, that they couldn't do. Right? They just didn't have any way of doing it. And in some things, I think also, we have better parsers, better understanding, and there's things that we've just learned, but also part of it is, change in hardware, change in networking causes us to think about problems in different ways than they ever did. And of course we learn from their mistakes, right?
Yeah, I agree very much, and this is why I also I also try to avoid moral judgments about code. When you said before, is value semantic just good code? I don't know, because I don't know what good code is. Maybe good code is code that helps old people cross the street or something. I don't know.
Well, but what I mean by what I mean by that good code is just that. It's easier to test. It's easier to reason about, right? Any paradigm you can have code where you say, I look at this code, I know what it's supposed to do, I can see how I would test it. It doesn't seem to have. It follows Scott Meyer's universal principle of design, which is that it's easy to use correctly and difficult to use incorrectly, right? That's just good code. And it doesn't matter what kind of paradigm you use. Now, some paradigms just naturally do that better than others, I think.
I know what do we mean by good, right? Because this definition of good changes over time. That's what I was getting to, right? Like now we can say, oh, this code that someone wrote 20 years ago is bad. Well, it's not bad. It's just that your definition of good has changed because your constraints are different. And there is code that is good for, is easy to change. There is code that is easy, that is performant. There is code that is easy to read. There is code that is easy to write. There is code that is easy to test. There are all these things, all these characteristics, and it's very hard to satisfy all of them at the same time, actually, right? And this is, when you go to talks, some people will focus on some aspect and poke at all the things that other people do wrong. But in the end, we're all smart people trying to do our best. and we often just have different constraints. So yeah, let's talk more also about what constraints, what trade-offs are we making when writing the software, which is basically what we do by designing, right? This goes back to the discussion about talking more about design. Design is just choosing constraints, and once you choose certain constraints, then it's like you put some dots in the map, and then you can do a drawing, and everything fits. But choosing the right constraints and choosing the right trade-offs is very hard, and it's a business decision. It's an engineering decision in the whole word, whatever it means in its greater sense. That's the whole thing.
Right. Absolutely.
There's a few things that I wanted to bring up, but we're getting a bit short of time, and we didn't really go through our news section.
We did.
There are a couple of items that I wanted to bring up there as well, and actually one of them, there is a link back to all of this, which is that there's a new version of Catch 2 out, version 2.9.0, and the big news there is that it actually includes the Nonius micro benchmarking framework has been merged in. And you might wonder what that's going to do with anything we've been talking about. The reason it's relevant is I did a talk a couple of years ago at C++ Now on persistent hash array map trees. It's a particular type of persistent data structure.
Was this just to get as many buzzwords in one sentence as possible? Was it?
That's just in one name.
Yeah, exactly.
You have to watch the talk to see exactly what that's about. It's actually really fascinating. And in that talk, I used Nonius as my micro benchmarking framework specifically. So that was fun. And in the audience was Juan Pedro, and we chatted afterwards. And before the end of the year, he'd actually included a persistent hash array map tree in his Immutable framework. So see, everything's connected.
Yeah.
So is the idea of this micro benchmarking so that you know if you have broken performance? Was that the idea?
Yeah, obviously you have to be careful with any sort of benchmarking, but particularly the micro benchmarking. It can really mislead you if it's often not testing what you think it is, but it can be good as a guide for certain things. So yeah, it's for just testing whether a particular operation which might complete extremely quickly is actually faster than some other comparable very fast operation. And in my case, it was like adding items to an associative data structure, for example, and how the different type of data structures have different performance characteristics. So even just like seeing the shape of that as you add more items, how that changes over time, that could be relevant even if the actual absolute figures aren't necessarily accurate.
All right.
This is funny because actually, the circle closes around Nonius because I also used Nonius as a benchmarking library for the immutable data structure library that I did, and I ended up actually contributing a couple of patches to their HTML report generator as part of that usage. And I can very much recommend this library. It's actually, I'm very happy that it's included as part of Catch. They play great together because it's nice also to include some kind of benchmarking monitoring as part of your CI pipeline and testing pipeline somehow.
Absolutely, and I should say I can take no credit for this at all because I didn't touch the PRs. That was all handled by other people, particularly Martin, as ever, overseeing that. So big thanks to him again. So I don't even know how it's come out, but it's in the latest release. So I've got to play with it myself. But I did start adding micro benchmarking framework to Catch a year or so ago, before the author of Nonius actually approached me and we talked about including it. And I wanted to get that in there because the face of it seems like they're completely different things. Micro benchmarking and unit testing, they are different things. And they did hesitate to do it, but in many ways they just run the same sort of way, and the same sort of approaches you might want to use apply in both forms of testing. So having a single place that you could do that, actually keep the code together, did actually make a lot of sense in the end.
So I didn't quite. I think there was a little glitch, and I didn't quite hear what you were saying when you were talking about how this works. Are you saying you write your test so that you do something with your code, and then you do something with some alternative, and that way it's isolating essentially the hardware? We could run this on a faster machine or a slower machine, because all you're really testing is not does it perform in so many seconds, but you're instead saying, does this method perform at least as fast as this method? Is that what we're saying?
That is one use, yeah. That's what I tended to use it for. Obviously, you can compare it against previous versions of the same algorithm, that sort of thing. But I think, comparing the relative performance characteristics of multiple solutions rather than just the absolute metrics is important. Even then, it can lead you astray, because obviously how you run something in isolation can differ in how it runs on the machine,
right,
compared to when you're running it in the context of a code and you get different types of cache warm-ups and so on. So you take it all with a pinch of salt.
And you also may have a situation where you've made the choice to slow something down because you've made it easier for the caller to avoid doing something even more expensive.
Right.
So
you might just want to measure what the cost of that is as well. So
yeah,
that can also be useful. So in the case of the talk that I mentioned about the persistent hash array map tree, I wanted to see the performance of this persistent data structure for storing associated data compared to just using std map, ordered map, std set, the containers. A particular implementation of those, because they will to make sure you won't get up too much, and in fact they outperform them in most cases.
So we should probably touch on anything else we need to touch on, because we're getting low on time here. I wanted to announce,
I think, negative 2 minutes.
Yeah, that's right. I wanted to announce that C++ Now, the videos are up. Some really great content there. I really don't know. I think the two that people are most looking forward to, and I'm not even sure if those two are up, but a number of people have remarked on Hannah's talk, because and in fact, her slides are available, and her slides actually include this magic where you can literally, in the slide, you can type in your regular expression and watch the state machine being created on the slide.
Yeah.
That's just
that is amazing.
And then the other one is Connor's talk, which won all the awards. So people are looking forward to that. Let's see. The Italian C++ and the Paris C++ are both over now. So I guess we're still waiting for videos on that. I saw a lot of tweets come out while Andre was speaking. His keynote at the Italian one got a lot of people interested. CPPCon, we're right in the situation where we've done most of the rating of sessions, and now we're figuring out which ones are actually going to be part of the program. I think Meeting C++, they're also in the review process. So if you are a previous attendee, I think you get to vote, so you can do reviews. Are there other news? Oh, we also have this announcement from Robert Ramey of this incredibly controversial blog post that he's writing. I wish we had time to talk about it, but I guess we're not going to be able to talk about it. I'll just everybody will just have to stay tuned for that.
I would say we should get him back on the show, but we should leave him some time to actually write this blog post.
Well, yeah, Robert, get that post written so we can have you back on. Anyway, until then, we'll wish everyone safe coding.
Safe coding.
Safe coding. Have a good one.